Good chance of it. Interesting. Hello, Peyton. Hope you're enjoying playing your Xbox and that you watch this later. All right, so if we're asked to evaluate a function rule for a given value, then if I have a function rule that is x squared and I'm evaluating it for 2, this we did the other day, right? We just plug that number in. So we would have f of 2 would equal, we'd put a 2 right there for our x squared. Do we do anything with this f of 2 over here? No, that is just telling me, hey, I plugged 2 into this equation, all right? So it's just labeling what you plugged in there. You don't do anything with it. It doesn't mean f times 2. It's just a label right there. Whenever you get to some different levels of math, it's going to be important to label that stuff. So I've got 2 squared. That's going to give me 4. Right? We've done this some before. For the second one, actually I've got 2 example 2s here. I'm going to go down here and then go over here. Change that to 4. 4 right there. Okay, so if I'm going to evaluate f of x equals 3 minus x, this one a lot of students get wrong. Okay? What? Is going to be 6. So Jada did it correctly because you do not replace the minus and you have to put a -3 right here. So those would both become positives and we would get 6. Okay? Sometimes you have more than one x. So you'd have, in this case, 2 times 5 minus 3 plus 5. We put 5s right there for both of the x's. So we'd have 10 minus 3 plus 5. That'd be 7 plus 5, which would give us 12. I think we're okay with this because you guys have done this some before. Something you have not seen is something like number 4, where it says if g of x equals 2x plus 3, and the domain of the function is -1, 0, 2, find the range. Okay? What is a domain? What does the domain give us? X values, right? So what that tells me is all of those are x's. So if I want to find the range, I'm going to plug these in, and it's going to give me the y. So if I do f of -1, that'd be 2 times -1 plus 3, which would be -2 plus 3, which gives me 1. So for my range, my first number would be 1. Then I'm going to plug in 0. So 2 times 0 plus 3. That's going to be 0 plus 3, which is going to give me 3. So 3 here. And then 2 times 2 plus 3. That'd be 4 plus 3, which would give me 7. So 1, 3, and 7 would be my range. This just gives you a way of, you got to plug in more than one number here. So it's basically the same thing. All right, questions? All right. Okay, now, this becomes important because we are heading into our linear equation unit. And one thing that we're going to have to be able to do is graph. Okay? So, there is one way that you can graph any equation. I could give you super crazy difficult equations. I could give you something like f of x equals x squared minus 3 over x plus 2 minus x. I'm not going to, but I could. And you could use the same method that I'm getting ready to show you to graph anything, right? Because every time you plug in an x value, it gives you the y value that goes with it, which you could put on a graph. So this is going to work for the simple linear equations that we'll be doing in this class. It's going to work for exponentials when we get there. It'll work for quadratics when we get there. It will work in the classes to come. It's just not the fastest way to do it at all times, but it's a place to start from, okay? So I'm not going to make you do these, but we could. So if I want to graph f of x equals negative x plus 1, then to graph that, I'm just going to pick some numbers to plug into this equation, okay? I am going to put a little note right here. Always choose at least one negative number. 0 and at least one positive number. Alright, so you can pick any number you want. Now, I would not suggest picking -7 because -7 is not going to fit on this graph that I have here. Right? You can pick any number you want, but you want to pick ones that will fit on the graph, and you need at least one negative number. You always want to pick 0 because it's an interesting point that we need to know a lot about, and you always want to pick a positive number. So, you can see my graph right here only goes from -4 to 4. So, Laura, pick me a number between -4 and 4 for us to plug in. 3, okay? So, if we plug in 3, we would just take our function. We'd find f of 3. So, we'd have -3 plus 1. -3 plus 1 is -2. So, my x-coordinate would be 3. The y-coordinate that I get that goes with it is -2. So, that means I've got the point 3, -2, and I want to graph it on the coordinate plane. Everybody remembers how to graph? X-coordinate, you go left or right, so I'd go to the right 3. Y-coordinate's -2, so I'd go down 2, so I'd get this point right here. Okay, Easton, pick me another number. Okay, let's try 4. Alright, so if I do... Thank you. Let me change that real quick to... And we're just working on those notes we were doing yesterday. Alright, so if I plug in 4, I've got -4 plus 1. -4 plus 1 gives me -3. So I'm going to graph the point 4, -3. Be right here. Alright, now I said you need to pick 0. Always pick 0. So if I do f of 0, it is going to give me -0 plus 1, which gives me 1. So I would graph the point 0, 1. Be right here. Okay, Zane, pick me another number. Okay, we try 2. I've got -2 plus 1, which would be -1. So 2, -1. Be right here. You're starting to notice something about all of our points for this particular graph. I said you need to pick a negative number. So, Jada, pick me a negative. Alright, -3. If I plug in f of -3, I'm going to have -3. What happens when I have a -3? positive, so 3 plus 1 is 4. So negative 3, 4, be right here. Alright, so whenever you do this, you should see a trend happening with your points. They should be lining up possibly in a line, maybe in more of like a curve shape. It just depends on what you're looking at. But right here, it looks like a line. So we're going to draw a line through our points. And this is, in fact, is a line. If I plugged in any number, even if I plugged in like negative 2.53, it would give us a point that would be on that line. Obviously, whole numbers are easier to go with whenever you do that. But. Okay, questions? This works for all types of equations, even if they're a little bit, weird. So, let's look at the second one. I've got x squared plus 3. So, Alyssa, give me a number. Alright, so if I plug in negative 2, that would be negative 2 squared plus 3. Alyssa, what is negative 2 squared? Perfect. It's positive 4 plus 3, which is going to give us 7. So negative 2 is 7. So I'm going to put that here. Julian, give me another number. Okay. Yeah. Alright, if I do negative 3, g of negative 3 is negative 3 squared plus 3. Julian, what is negative 3 squared?
Negative 3 squared is the negative 6.
Nope. It's not negative 3 times 2. It is negative 3 times negative 3. Positive 9. So 9 plus 3 is going to give me 12. So negative 3, 12 will be this point right here. I'm thinking I might not want to pick negative 4. It looks like it might go off the graph, right? So what number I tell you always need to pick? 0. Let's try 0. So g of 0 is 0 squared plus 3. 0 squared plus 3 is 3. So 0, 3 is right here. All right, Caroline, give me another number. Just a number to plug in. What do you want to try? Okay, let's try 1. So g of 1 would be 1 squared plus 3, which is going to give us 4. All right, Katie, what other number you want to try? 3. So g of 3 is 3 squared plus 3, which is 9 plus 3, which is 12. So 3, 12. What do you think about this? What's this look like? A little bit of a V?
Yeah.
It's kind of V-shaped. Let's try a couple more numbers just to see. I'm going to plug in negative 1. Okay? So if I do g of negative 1, that's negative 1 squared plus 3, which is 1 plus 3, which is 4. So negative 1, 4 is right here. What does it look like when we plug in a negative and a positive? I plugged in negative 3, I got 12. Plugged in positive 3, I got 12. Plugged in 1, I got 4. Plugged in negative 1, I got 4. What does it look like it's happening here? Oh, I like that word. It's symmetrical. So what do you think if I plugged in positive 2, what do you think I would get? 7. The same as if I plugged in negative 2. So if we connect these, it's not so much a V, it's more of a U shape here. Later in second semester, we'll learn that that's called a parabola, and we'll learn a lot about graphing those. But right now, we're just trying to connect the points the way that they look. So if you ever have to graph something, you can just plug in all the points. All right. I want you guys, did yours get sent down to the next line, or is it? Yeah, okay. All right, so your equation here, it got skipped, but it's h of x equals absolute value of x minus 3. Okay? I want you to try this one on your own. Okay? Pick numbers to plug in. Make sure you use 0. Make sure you use at least one negative. Make sure you use some positives. You can tell by the way I have set up the graph here, it looks like you probably want to use more of the positive numbers than the negative numbers, but use at least one negative there and see what kind of graph you can get for this. Let's see if you can get the picture of what it looks like for this. What absolute value bars need to do? It doesn't mean to add them. So let me do one together just so we're on the same page here. It doesn't mean to add them. What it means to do, like if I'm doing, let's go ahead and do h of 0 because I told you you got to do 0 every time. Absolute value of 0 minus 3. You treat it like parentheses at first. You're going to do what's on the inside. 0 minus 3 is negative 3. All right, so you'll have absolute value of negative 3. Absolute value is the distance a number is from 0. Distance is always positive, right? One of my teachers taught me that the absolute value is like the washing machine, and it washes away all the negatives. Let's think of negatives like dirty clothes. If you throw dirty clothes into the washing machine, it's going to wash away the dirt. They're going to come out clean, right? What happens if you throw clean clothes in the washing machine and wash them? They stay the same, but they still come out clean, right? Everything comes out of the washing machine clean, whether it was clean when it went in or not. So everything comes out of the absolute value is positive, even if it was positive when it went in, right? So it's just a positive 3 there. So 0 is positive 3. So you're going to do what's inside of the absolute value bars first, and then if there is a negative, you got to wash it away. You might need to put in more numbers than will fit in your table there. Sort of. Parts of it will look kind of like it. Yeah, that should be right. Yeah, that's right. You might need to plug in some more points. Yeah, probably wouldn't be able to afford to because you run out of room every time you graph it. If you had a bigger graph, you could plug it in and fine. But yeah, possible would be better. Plug in there. value bar washed away the negative. So you should have a point 0, 3, which is right here. That's all we got right. So 1 minus 3, what's that give you? Negative. So what does it to the absolute value bar? It takes it away. So 1 will be positive 2. Okay. Yes. Yes. I think you're graphing yours backwards. So 0, 3 looks good. 2, 1, good. X for the concern. 2, and then up and up. It should be right here. I think you're graphing this back. I think these are errors. Let's see. If you're plugging in, plug the same number in. Okay. So if you want, I plug in 0, right? 0 minus 3 is negative 3 because washing machine washed away the negative. So like it looks like, so you're changing this minus 3. That doesn't change it. It's hard to do. So when you want to plug in 4, you put 4 right here. And you just replace the X with 4. So it'd be 4. Nice. That's not right. Yes, it'll be 0. 0 is 0 positive. Alright, let's see. Pretty good drawing along. Still not right, huh? Alright, let's see. I think your numbers. Okay, the graphing. So we graph 0 and 3. 0 and 3 is right here. You gotta graph 2, 1. 2 will go to the right, 2 to the 1. So that one you had right there was correct. So these are not graphed correctly. Absolute value of the washing machine. You should, so it washes away all of your negative. So you should, so you don't, and you don't have any negative, so it should never go down below. It's not a straight line. Also, please put your mask back up. Hello? That's all right. Yes. Alrighty, I'll send her up there. Thanks. Bye. Gee, Presley. Bye, guys. Love you. See you in a couple weeks. You said go ahead and bring your stuff. Oh, you got any questions? So you might be back. Well, I can't come back, but I'm not looking for you.
For this one?
Yeah, we walk the same. Oh, she looks even worse.
Alright.
Wait.
Okay, I like what you got. It looks good. Well, except for that one.
Yeah, that's what I did.
Which one was that? Do you remember? Alright, so negative 1 should be negative 2.
Okay.
Because if you plug in negative 1, what's negative 1 minus 3? Be negative 4. So that's the same sign. But absolute value bars are the washing machine. They're going to wash the negative away. So it should be a 4 right there. So negative 1 should be 4. Alright, I'm going to borrow yours.
Good morning, everyone. If I could please have your attention, please excuse this interruption. For the next few minutes, we are doing some maintenance on the fire alarms. The fire alarm may go off. However, if it does go off within the next hour, please remain in your classroom and do not evacuate. However, after the hour, if at that point the alarm does go off, we would need to go back into the regular evacuation mode. Again, if the fire alarms go off within the next hour, please disregard and stay in your classroom. Thank you.
What happens when the fire alarm goes off?
Then we just sit here with, well, But if it goes off, we're all going to want to get out because it's terribly loud and annoying. Hopefully, if it does go off, it's just for a second. And goes back. They do this all the time once kids are gone and teachers are just here. And if it ever starts going off, sometimes they just pack up and go home because it's so annoying. All right, let's see what some of you got here. I got a few that I have recruited for. All right, so the problem with this method is it depends on what numbers you pick. All right, everybody back to your seats. Everybody quiet. I'm going to show you what we've got up here, and you can adjust what you've got accordingly. I've borrowed this from a few people here. So, here's one that I have. All right, so this is one that I have, and I think all these numbers are correct. I think they look good. But whenever the line's drawn in, it is not exactly what matches this function. Okay? But their numbers are fine. Okay, here's another one. This person did a few more numbers. Okay? This is Easton. He's got a few more numbers. So his picture, it still looks a lot like the last one, though, right? It's a lot like the last one. Okay? Alright. Here, Zach's. Okay? Zach didn't use as many numbers, but he picked one number that really made the difference here because neither one of them picked 3. And 3 is the point where you're going to hit that x-axis and then turn back upward. Absolute value graphs are going to have this V shape because there's a certain point where things start becoming negative and then it starts washing away the negatives, which sends it back up. So, whenever we're using this method, it is imperfect, right? Because if we don't pick the right numbers, sometimes we might have all the numbers that we need, but we don't get the full picture of the graph because we didn't pick the right numbers. If you're really wanting a good graph, you should probably just do every number and graph every point there. But Zach's is correct, and most of you guys were getting the correct numbers, but maybe didn't have the line drawn in correctly. But this should be a V shape that goes down, touches the y-axis at 3, and then goes back up. So graph that on your paper there, and we'll give y'all back here in just a second. And make sure yours looks like that. Yeah, 0, 3 is the point right here on the graph, which is another important one to have. But if you didn't pick 3 to plug in, and there was nothing I told you that told you you for sure need to pick 3, right? It's going to be, that's what gives you that turning point there that you see. All right, so make sure you have yours right on your paper. Yes, make it look like this. You don't have to change your table, but make sure your graph looks like this. Okay? Questions? Please take your hoods off, please, fellas. Right here. Over here. It's -1, 4. And it's okay if you don't have all the dots the same. I just want your lines filled in where you got that V shape like this. Okay? All right. So, let's continue on. We've got some more things we need to do here. look at for this stuff here is looking at some word problems where they give us functions. These problems look really difficult, but they're usually actually very easy to figure out because they're usually just asking you to plug in a number. Okay? So if you see an equation that has, let's see. If you see a big long, don't do that. If you see a word problem that has a function in it somewhere like this, then it's probably just wanting you to plug a number into that equation. Okay, so read it carefully and try to figure out what it's asking. All right. So suppose your group recorded a CD. This came from like an Algebra 1 book whenever I first started teaching. So I realized you guys don't have CDs and maybe have never had CDs in your whole life except for when you were like little kids. But y'all don't know. Yeah. Alright. My 4-year-old, he got a CD at church because we had this, like, guy come and sing, and he had, like, CDs afterwards, and Henry really liked him, so I got him one of the CDs, and he was so excited about having a CD. Because he had never had one in his whole entire life. And the only thing we have that, like, I have a CD player in my van, but it's the only CD player we have in the whole house, so it'll play on the DVD player, too. Anyway, so sometimes these are outdated. I made a problem the other day for calculus that talked about a car and a gas station, and the question entered my mind, will I ever see this become outdated? Should I change it to like a charging station? Like, will it ever be? I'm thinking not in my, like, career. Not in my career, I don't think. Like, all gas stations replaced with electric vehicles or stuff. I don't know about that. I wouldn't say it'll never happen, but if it does happen, it is going to take a very long time to switch over take a very long time to switch over to everybody having electric vehicles because we don't have the infrastructure for it. You don't have charging stations everywhere. You don't have it. Some of them are pretty cool. But I've ridden Miss Ball's Tesla before, and it was pretty cool. Was it the expensive one? Because hers was the expensive one that's fast. No, I'm talking like more. That 50 grand's the cheap Tesla. Yeah. Well, he just got the cheap one with a lot of fancy stuff on it. Their expensive model is like 100 grand, and it's super fast, like crazy fast. It's crazy fast. Like, I have ridden in some fast cars before, not a ton, but Miss Ball's Tesla was crazy fast. So, I don't know where it'll go. And there'll definitely be some resistance, but it could.
Oh my God! Oh,
All right.
mercy! Hold up, crap!
How old do you have to be? You have to be like 18.
For what?
For a microphone.
Oh my God. Oh.
Do some lunges. Hurry. Where'd she go?
Dig it in.
Are you okay? No.
This is the first time anyone's ever cramped up during a math class for me.
I'm never cramped up.
Alright. She's experiencing a cramp. We're going to let her Maybe a hair of that also, but we'll let her have her stretch over here. Hopefully she's going to make it. All right. So, all right. So you got a CD. You want to copy and sell it? One company charges $250 for making a master CD and designing the art for the cover. There is also a cost of $3 to burn each CD. The total cost, P of C, depends on the number of CDs burned. Use the function rule, P of C equals 250 plus 3C to make a table of values and a graph. Okay? So, let's think about in actuality here, and we'll use a calculator on this one since we're dealing with some numbers that are going to get a little bit bigger. We're not quite to the point where we're going to use calculators much, but towards the end of this semester, it's coming where we'll use them more and more. So, my C is my value here, and then I've got P of C. What does C stand for? Number of CDs. And P of C, what's this equation giving me? If I say P of C, it says total cost, right? So total cost. So obviously if we had 0 CDs, and I plugged in 0, I'm going to do it on the calculator, 250 plus 3 times 0 is going to give me, actually I'm not going to do a calculator because it's going to be 250, right? So it costs you $250 no matter what just to get this done. So like if you were to actually do this, because lots of people do this, that are like small time artists that have CDs that might sell at shows and stuff like that, you're going to pay a certain amount to get recorded and have it all made. My husband did this back. It's been a little while now with a group that he plays with. So like you have to pay so much to get everything recorded and set up. It's usually a lot more than $250. But and then you got to pay a certain amount when you order the CDs, right? So you have to pay $2 or $3 per CD for the company to make them and ship them to you. So let's say that they got 50 CDs, right? Because we wouldn't want to put one. You're not going to do this and only get one CD because you're probably doing it to sell them at some point. So let's do 50. All right, we do 250 plus 3 times 50. And that's going to give us 400. And then maybe do 100. So if we do 250 plus 3 times 100, we would get 550. 150 would be 250 plus 3 times 150, so 700, and then let's do 200, and I think that'll be enough. So 250 plus 3 times 200 is going to give us 850. Okay, you could keep on going, but we're going to stop just because you could go on forever, right? So we're going to make a graph of this, and I didn't give you a graph specifically because we need to scale our axes here, right? We're not going to do 1, 2, 3, 4, 5, 6 because we got to go up to 200 on the x-axis. We got to go up to 850 on the y-axis. So what right here we're going to put number of CDs. We're going to label it, and I would probably count by 50s here. So we got 50, 100, 150, 200. And then to be able to fit everything here for the cost, I'm probably going to need to go up by 100 here because I don't think I can fit 550s up this way. So I'm going to do 100, 200, 300, 400, 500, 600. Oh, should have. 700. I think I can drag all this down just a little bit. No. Alright. There we go. Move this up. Okay. 800. 900, that'll be enough. So 0, 250, 0, 250 would be right here. 50, 400 would be here. 100, 550 would be about here. 150, 700 would be here. And then 200, 850 would be right here. And mine does not look like a perfectly straight line, but it should be. But whenever you draw these by hand, sometimes it doesn't look perfect there. Okay, so you could set this up. This would be important to know if you were doing this, and you could set this up. You could even use, like a graphing calculator to find out more here. All right, so here's another way outdated problem. It might still apply if you're calling like outside of the country, but pretty much everybody has cell phones now, and all of them have unlimited, calling within the U.S. You can call somebody in California. It doesn't cost you any extra. But in the ancient days, whenever you wanted to call outside of your calling area, you had to pay long distance fees. Like I can remember that being an issue in my life, so it's not that long ago. But so for one calling plan, the cost of a call from Sacramento, California to Salt Lake City, Utah is a function of the number of additional minutes after the first minute. The rule C of A equals this. Here, C of A is the cost of the call, and A is minutes. I don't know if that should say additional minutes. I think it should say, let's just say it's the number of minutes, because I think the way this equation is set up, it should be. So number of minutes of the call. So it looks like a complicated formula, but we can just, if we want to know how much a 5-minute call costs, we just plug it into this equation. So C of 5 would be 0.27 plus 0.11 times 5 minus 1. And so we would have 0.27 plus 0.11 times 5 minus 1. And that would give us 71 cents. Okay, here's one that's a little bit different. How many minutes can you talk for $1.50? So, A is my number of minutes, right? A is my number of minutes. So I can't plug 150 in for A because 150 is a dollar amount, right? I need to know how many minutes. So in that equation, C of A equals 0.27 plus 0.11 A minus 1. C of A, that's what stands for my cost, right? But C of A stands for my cost. So in this case, I know the cost, but I don't know the minutes. So I'm going to have to plug $1.50 in for the minute or for the cost. Now that doesn't look the same as before, right? What does this look like? How do you think we could figure out what the A should be here? Okay, what'd you say? Just solve it. This is an equation. We can solve it. All right, so this is what we've been learning all that solving equations for. So we could distribute this, and we'll use a calculator on this since it's got so many decimals. All right, we just distribute that 0.11. Then we would need to combine our like terms. So we got 0.27 and negative 0.11. So that is going to be, stay where you're at.
That scared the crap out of me.
Yeah, me too. Okay, good. That's not going to go on very long. Hopefully. All right. Okay. So, we would combine these. Then, Passion, what would we do next to solve that? We're not going to get rid of that yet. We do want to try to get that. Yep, 0.16 we're going to subtract. So that's going to give me 1.34. Divide by 0.11. And we will use the calculator for that one. I'm pretty sure that's not going to go evenly. It's going to be 12 something, I think. Yep, 12.18. So you can talk for 12 minutes.
12 minutes for like, so it's 1.50 for each minute, right?
No, it was 12 minutes would cost you $1.50.
I thought it would be like less.
So whenever up here it was 5 minutes and it cost 71 cents. So for 150 you can talk for 12 minutes, which is a little bit more there.
And we're talking about like page phones.
It was even on your house phone. You had to like dial whenever you called long distance. It was going to be like charged extra. So you had to, if you had family outside of your calling area, then that was something you might have to get like special plans so it didn't cost as much because it could get really expensive if you called long distance. Some of that might still apply, like if you try to call outside of the United States, but I'm pretty sure that. I'm not sure. I want to say probably so, maybe. I don't know.
I tried. It worked.
And they don't have to do any like extra. Yeah. Whenever I was in Mexico, you still had to do. Yeah, because you got to do the country code on top of the But yeah, you still had to have like special stuff then. But things have changed a lot in the last while on that. Okay, so I'm gonna give you guys not our Excel, classwork. We may not get the Excel today.
Yes. Worksheet. Worksheet.
Guys, quit asking it. It drives me crazy when you say, "Is this for homework? Is this for homework? Is this for homework?" Don't ask. I will let you know in class. And when you say, "Is it going to be homework?" It imagine that you have a job to do, and that job is to, all right, so tables give you the values, so you don't have to find those values. They're given to you, right? So if it asks for me to find f of -3, okay, that means this f of -3 is telling me that x equals -3, and I want to find the y coordinate, or the f of x coordinate that goes with it, right? So I will go here to -3, and what is the coordinate that goes with it? 2. So f of 3 equals 2. There's no work. You don't have to add, subtract, multiply, divide, anything. So, let me check in with you. Hank, what is f of 20? It'd be 0. Good. You're just looking where the x value is 20, and you're finding the 0, the y coordinate, or the f of x coordinate that goes with it. All right. So we're going to skip C and D. You can do this on here. All right. Let's look at E, because here's where it's a little bit different. E says if f of x equals 9, what is x? It is not 4 here. It is 2. So they're telling you f of x equals 9. F of x column is right, or row is right here. So this is like saying the y coordinate is 9. The f of x coordinate is 9. So this time, when it's worded like this, you're going backwards. Okay? You're finding where f of x is 9, which is right here. And they're asking what is the x that goes with that. The x coordinate would be 2. So it's backwards if it's asked this way. If it says f of x equals, then that's your y coordinate. You're looking on the f of x line. So, yes. Not for D. D is wanting you to look at the pattern, I guess, on that one. We're not going to get into that, actually. Yeah, we're not worried about that, finding that pattern right now. I think that means I also need to take out H. I think H kind of does that same thing. All right, so Easton, if f of x equals 4, what is x? 8 or 9, right? Because you got 4 in 2 places right here, so x equals 8 or x equals 9. So it could be either one there. All right, so let's look at the last 2 here. We're going to do one of these. Or last few here, we're going to do one of these also. Scroll this up. All right, so here they give you f of x. They say if f of x equals 15. So they're not saying f of 15. If they say f of 15, it just means plug in 15, right? But that's not what they're saying. They're saying f of x equals 15. So when we see it this way, we have to take f of x and replace it with 15. So I'm going to have 15 equals 2x minus 3. Okay? So, Julian, what do I have to do to solve that? Yep. So we got 18 equals 2x. And then? So x would equal 9 to that. So do you guys see the difference there in finding f of 15 versus finding if f of x equals 15? So where you plug it in is different there. All right, so I think that covers everything that you'll need to know, except for possibly when you get to the graphs at the end, but I think we won't have time to get there. So I want you to do as much as you can of this, and the amount that's going to be homework is going to depend on how well you're working. So everybody work hard there.